Hi, my name is Clea Zolotow. I'm a distinguished engineer and master inventor at Kyndryl Corporation. Today, I'm working in the mainframe area, responsible for systems architecture and service capabilities. I do a lot of work with mainframe extensions with hyperscalers.
Hello, my name is Marci Formato. I'm a principal architect at Kyndryl, and I've spent the last 25 years of my career working with data from the perspective of management, integration, and protection. And today I'll talk to you about integrating mainframe data with cloud functionality.
Applications outside the mainframe have a need for utilizing the IBM Z and IBM I systems of record in order to connect to the data and files located in those environments. Many mainframe application owners have investigated software utilization decreases in order to read, move, or transform data off the mainframe for mainframe cost savings initiatives. Various types of extract, perform, and load processes have been created, some homemade and some utilizing tool sets such as IBM DB2 Distributed Data Facility or Microsoft's Host Integration Server. With the advent of the hyperscalers, there are now many tools from API enablement to value-added SQL optimization that can provide local and remote connectivity and data integration between non-Z and IBM Z or I environments, while also supporting a full DevSecOps life cycle. Integration pathways range from reducing latency via proximity to virtualized access, analytics, and governance in the full DevOps process. Here, we have some selected technologies and best fit examples for particular use cases. The systems of engagement use cases we have chosen include interactive data analytics for batch ingestion. This file-based process utilizes business data for both scheduled and ad hoc data analytics. In this use case, the data will remain on the cloud but get fed and refreshed by the systems of record. A second use case is the normal transactional replication-based integration, such as CICS systems of record utilizing a web-facing front end located in the cloud. And the last use case is a message-oriented middleware integration, utilizing something like Kafka. Message-oriented middleware is a concept that involves the passing of data between applications utilizing a communications channel. This channel carries self-contained units of information, in other words, messages. In this environment, messages are usually sent and received asynchronously and usually only deal with changed data.
A data pipeline is a system to capture, cleanse, map, and route data for cross and multi-platform workloads. Pipelines can be designed with cloud agnostic and or system of engagement specifically designed for particular hypervisors. The goal is to automate the delivery and transformation of data and to make it more available for analytic and application use cases. For example, Microsoft's Host Integration Server is an out-of-the-box tool suited particularly to Azure's cloud. IBM ZOS Connect is a multi-cloud solution and allows for more API integration points. The connectivity to DB2 data can be done simply with other DRDA-compliant platforms, or one may use IBM's DVM for more complex integrations. A decision matrix can be used to help identify and define the business purpose toward evaluating the right data access and pipeline architecture options. There are several basic types of pipeline components, and the choice depends on the business purpose. So for example, if we are looking at an application integration use case, we may use data virtualization for applications that are chatty but not performing transactions back on the system of record. We can use APIs with transactions, and we can use it either with virtualized data or in the case where the source platform has native API, may use it directly. Data integration use case has a number of options, and quite a lot of it depends on the timeliness requirement of the data. Batch can be done either as extract, transform, and load, and very similar to the way it's done today, or it may be done as extract, load, and transform, where the transformation takes place on the source hypervisor. The target, at the target hypervisor. DRDA and data virtualization are also choices for data integration. And again, data virtualization is the idea of taking multiple data sources that are normally not compatible, combining them into a virtual table to be used either directly or through an API with the addition of an API product such as ZOS Connect. In-memory compute is an option when the data sets are particularly large and the analytics can be suited to run on zip engines using products such as ZDIH, which does the virtualization and also provides a Spark cluster from GridGain. Event streaming is an option when the data needs to be significantly more closer to real time than a batch solution would permit. Data copy or migration are replication techniques that can take advantage of batch and or continuous data copy. Often during a data migration, one might use batch to get the bulk of it and then a continuous data copy for the final synchronization. System metrics may be analyzed in a hypervisor environment, and normally event streaming is used for that, not only for analysis but for monitoring so that the nearest to real-time acknowledgements can be made. Once the business purpose is determined, we then evaluate appropriate other options for the pipeline based on some additional considerations. We evaluate the methodology options for the data pipeline based on some additional considerations. For example, as mentioned, if the application is transactional, we would require a REST API from ZOS Connect, Adaptogent, or other API providers. In other words, we can use DVM. Rocket has a virtualization product, as do many other companies. Data gravity is the idea that large data sets attract a diversity of applications because of the diversity of information contained within them. However, because of their size, it may be difficult to move the data, and it may be expensive. So we have two options. We can bring the data to the analytic engine, that would be moving the data, and we would use batch or event streaming for this type of thing. Or conversely, we can locate the analytics where the data resides. When the data is on the mainframe, this is the use case for in-memory computing, such as ZDIH. And when the data is on the cloud, we would use cloud-based products such as Azure Synapse. Along with these decisions have to do with latency tolerance, again with the use case of system metric monitoring and analytics. We would use a log or an event stream. And in the case of business analytics, where we're looking to gain insight from our business data, batch is more likely an effective method. And as always, the age-old question of build or buy applies to this, as does vendor portfolio lock-in. We thank you for your time and attention today and hope that you found this presentation informative. At Kyndryl, we've developed quite a lot of material that helps explain and design integrations between mainframe and cloud. Please visit us at our website and feel free to contact us. We look forward to hearing from you.